Thank you all so much. And at the outset, I'd like to thank my lifelong friend and colleague, Professor Israelian, President Sarkisian, and Martin Sarkisian for this great honor. Over the next 15 minutes or so, I'm going to take you through a very fascinating tour. This is a little bit of Fantastic Voyage combined with the movie Inner Space, which some of you may be old enough to remember. I'm also going to give you a sort of a molecules to human story about basic science, because that's the engine that drives research universities such as ours. I will also conclude with something that you can take away with you today that will empower you. So what you heard from many of the speakers today has relevance to the talk and what I'm going to be telling you. So if I could have the first slide. So there you go. So this is the story of how every organ, in fact, every cell in the human body is talking to the nervous system, and this communication is back and forth. That is the first panel in that figure. The other two figures, of course, comes from an artist who started off as an artist, but went on to win the Nobel Prize, and that is the images painted by none other than the famous scientist Cahal, who actually told us what the brain is, what neurons are. So using this as our background, let's dive into something immediate. So if you looked at Oxford University, I have an appointment at that university, and one of the treasures at Oxford is the data that they show the world. So if you looked at the data, what are people dying of on planet Earth? These are the numbers, and it's a stunning number. When you look at it, I'm a cardiologist, and the reason why we always worry about your heart is because 19 million people die every year because of heart disease. And it turns out it's more than all other causes of all cancers combined. Not to minimize any suffering or other diseases, but just it gives you the context. Of these 19 million people, 12 million, which is the lower panel of the slide tells you, die suddenly. So that is 22 people dying every minute. Forget about the jumbo jet that crashes, the analogy that we heard earlier today. Just look at the amazing impact, negative impact this is having on mankind. So that is the purpose of, someone said, what is the purpose of our lifespan and health span? Is to take a bite out of this problem. And it turns out this places an undue burden on health systems. In fact, vast majority of these people who die suddenly, it shatters entire families. People at the most productive phases of their life, where they are bringing food to their entire family, die. So this is a big problem. We need urgent, low-cost, globally applicable therapeutics. So how did this go about? So I'm a physician. I'm a blue-collar physician. I'd love to sit down and talk to you about patients. So let me tell you about this patient, and as it turns out, since I practice here in Westwood, a little while ago you heard a helicopter. This is typically 90% of the patients I personally operate are patients like this, who are airlifted, who are in extremis. This is a 49-year-old patient who's dying, is being airlifted, is on a ventilator, getting shocks. Shocks means electrical shocks that the EMS has to give because your heart is beating too fast. Death is imminent. So these are the kinds of patients we treat, and what we do is, this is our version of a special mission. There are times when we operate for 8-10 hours in a patient's heart. These are catheters. In the right panel, the movie shows you, these are catheters, wires, electrical wires we thread into the heart. We find very specific regions which are behaving abnormally, and we zap them. The panel on the left actually shows you an image of a heart, and the area where you see a little bit of the light shining towards the front of that image is an area where there's a scar in that heart. So that is the enemy. That is what causes this problem. So we've come a long way in the past 2 decades in moving catheters, being very precise about fixing these problems. However, there are times, no matter what we do some very science fiction procedures that is not able to fix the problem. So what do you do in those settings? You can't let a patient die. We have a couple of options. We can transplant. Like you heard about liver transplants, heart transplants are an option, but you can't snap your finger and get a heart. There's only several thousand transplants being done, even in the United States, where the entire society is set up to help get organs. The other option is you can implant a total artificial heart, which the technology is not yet there. And even that is a massive undertaking, and it cannot be done immediately. So what would you do in that setting? Because of what happened, what I would refer to as a battlefield decision, we picked a intervention. This, of course, 100 years ago was used for treating heart problems. And that comes from the fact that the heart is connected to the brain. Now, let me rewind a little bit. 1994, many of us were here in LA. This is just a year before I moved to LA, and I was thinking to myself, man, should I go to UCLA? This is like, it's one more worry over here. 1994, 4:31 in the morning was the strongest earthquake ever recorded in a major city in North America. This, fortunately, did not result in a huge loss of life due to physical trauma, but it did result in an amazing amount of medical deaths. So, yes, this happened. Yes, there were deaths because of trauma, but that was vanishingly small compared to the proportion of deaths that happened because of sudden cardiac death. There were more people who actually developed a heart attack, developed a rapid heart rhythm, and died. And this, we now know, has been shown in the Kobe earthquake. Interestingly, it has also been noticed after intense sports games. So this tells you the brain-body connection, all right? And by the way, for some of the other people in the new digital age, you're not safe just because you're playing video games. Video games can also cause that. So brain, heart, brain-body connections are very important. So this, again, gave us an idea, and at that time, this is typically any bright idea that comes from a guy usually comes from a wise woman in his life, which in my case was my spouse. And we were discussing, and we said, why not actually try to do a neural intervention? Because people said, oh, there was a procedure where we could cut the nerves that connect the heart to the brain, which was done 100 years ago. So if you went to a cardiologist and said you had angina or chest pain, there was no medications. They would send you to the surgeon to snip the nerves. Now, it turns out, for multiple scientific reasons, if you can cut that connection between the heart and the brain, it is actually life-saving. So this is one of those areas where we had a great collaboration with our surgeons. So there's something called video-assisted thoracic surgery. The details don't matter for this audience, but it's pretty cool. You can actually get to the nerve and cut the nerve that connects the heart to the brain. This was life-saving. Now, it turns out this opened a completely new chapter in our scientific lives. And much to my sort of joy, and this is something that was mentioned later years when I was promoted to a tenured professor, and that is the procedure, that things that we published here at UCLA help patients we never get to see because of the scientific papers that appeared. And this also opened the door for a completely new area of basic science. And I'm going to tell you how that works. One of the new drugs that we've actually have repurposed and sort of built new molecules comes from a plant in Africa, which can actually hack into the exact same nerve pathway that connects the heart to the brain. And if you apply this drug, you can actually prevent the heart from getting worse, and you can prevent a patient ever becoming to a stage where they would need a heart transplant. Pretty cool, right? So this is a form of hacking the nervous system to cure heart problems. And this, we think, is the kind of basic science at the bedside that can have a global impact. So let's sort of take the story further. And I think some of the biology and medical people in the audience would know, if you opened up, and any of you open up a medical textbook, you would see a picture like this, which is all the organs that are listed in the middle. You can see eye, lung, heart. And you would see that it has lines, which is nerve fibers, that connect it to the nervous system, the spinal cord, the higher centers. Now, it turns out that this tells you that there are physical structures, like cables, that is connecting the organs to the nervous system, and there's a lot of traffic. Like internet traffic. there's a lot of information that is being exchanged, millions and millions of impulses every second. And this is kind of how the entire human body works. Now, it turns out this is an area that brought us back to the basics, and we realized calling ourselves cardiologists, gastroenterologists, or nephrologists, these are just words we use. But the principles of biology, the principles of how this magic machine, the human body, which you probably saw in the second talk today, there was a beautiful section you saw from head to toe from the Visible Human Project. That was such a beautiful image. I was transfixed looking at that. Every one of those locations, every single cell in your body is connected to the nervous system. Now, if this is a project I'll be alluding to toward the end of my talk, here we have done a very detailed dissection. This is the chest of a human being. We've removed the lungs, and what you see colored in yellow are the nerve fibers. Now we are looking at it from the back. You're going to see the spinal cord. You see how delicate and how beautiful this is? These cables, these are the nerves that go to your lung, your heart, and of course, many of them that go below the chest, they go into the intestines. These are the nerve fibers that control every breath you take, and every heartbeat of yours is controlled by these nerves. The entire biological internet traffic is going through these cables that ultimately connects to your higher centers. So learning about these nerves, finding out where they are and hacking them has a huge impact, we think, in biology. And we already see this happening. Hot off the press, but based on science for the past 2 decades. Rheumatoid arthritis, terrible disease. Some of you may have had friends or family members who have had this tough disease. This can now be treated by placing an electronic stimulator in the vagus, which is a nerve in your neck. That's the image that I showed you before. And that electronic stimulator, which is a small pacemaker, is now able to control a joint disease. First case I showed you, I'm fixing a heart problem by cutting a nerve, not even touching the heart. Now we are fixing a joint pain problem by not going to the joints, but we are hacking the nervous system. It turns out this is based on extremely exciting science. And in fact, the science that really fascinates us is quite apropos to what Dr. Azraelian had this panel with Dr. Michelson and Dr. Beldegren, and that is the immune system. So this is the magic of the human body. So one med student once asked me, you're saying all these nerves control organs, but what about circulating lymphocytes and blood cells? That is the story. What you see there in that image over there is a lymph node. The shiny fibers you see over there are nerve fibers. So when these lymphocytes actually go inside these lymph nodes, they latch onto the Wi-Fi of the human body, and those lymphocytes get reprogrammed. This is hard science. We now look at drug prospects based on what happens over here. So this is the magic of what is happening in the human body. So you can modulate the nervous system and treat multiple diseases. What about colitis? Terrible disease. These are the problems that gastroenterologists deal with. And what about asthma? These conditions are now being treated using electrical therapies. So, and that is the neuroscience-based therapies, which is going to be a completely new era in medicine. And last but not the least, we talked about, big problems, right? Cancer. What about cancer? It turns out cancer is very powerfully controlled by the nervous system. So anytime a tumor forms in the human body, those cancer cells are sending signals to other parts of the nervous system, and it starts a whole cascade where 2 things happen. One is it hacks the nervous system so the tumor can grow. It also does something very bad. It suppresses the immune system, which would have killed the cancer in the first place. So that's kind of how cancers grow. And we now think that we can target these nerves. We can visualize these nerves, as you can see in a study. This is data from UCLA that actually shows that you can actually use state-of-the-art techniques like MR tractography to identify these nerves, and we're going to be intervening on these nerves to fix cancers. Now, it turns out, we're after all in LA. Everybody wants to look skinny and good, and we're going to go beyond Ozempic. How is that? It's called neural control of metabolism, and one of the big areas of science, and there's already exciting work that has come up, and that is we looked at special areas called brown adipocytes. These are fat stores in the body that deal with what is called non-shivering thermogenesis. We can actually hack into those nerves, and if we can actually stimulate it or modulate it, you don't have to take your Ozempic shots. And in fact, there's some theories to say that exercise probably activates these nerves, which is why you have benefits. And finally, I'm going to leave you in the last minute or two with a heavy topic. When we started our research, we thought, we now need to get the very best maps of the human body. We found a text which was published in the early 20th century, very detailed, 10-volume, remarkable gold standard of a book, and it provided amazing maps of the human body. You see those fine little nerves, it's painted. This was done by a team of really, really talented people. I thought, my problems are solved. We have a great sort of a foundational book on which we can build. Now it turns out this book was published until the 1990s, widely used, and the more detailed works were available. But there was a suppressed history. The guy who wrote this book, this is the picture of the first lecture that he gives in Vienna. This is not a political rally. This is a dean of a medical school giving a lecture. This guy, Pernkopf, was the one who published those atlases. I was very revulsed. I said, what the hell do you do in a moment like this? These were artists who used Nazi insignia in their signatures, proudly displaying their hatred. This was really problematic. In fact, 80% of the texts that we used in anatomy were polluted by this information. So people said, acknowledge this problem and go ahead, use these books. But I was really bothered. I said, why do we have to choose? So we started a very interesting project at UCLA, and that's called the Amara Yad Project. Amara in Sanskrit means immortal, Yad is hand. And this project is an open access knowledge portal, and I have many of the people, donors who support this project are in this audience. My heartfelt thanks to them. So we made this open access available to the whole world. So you can grab the QR code and download these atlases. We are now using the power of AI and computing to bring this data to patients. So the next time you come to UCLA for procedures, and in many hospitals around the world, we are already using some of the data that we obtained both from the Amara Yad Project, combined it with the power of computing. So we are now able to, even ahead of time, before we do a procedure, we have an extremely well worked out three-dimensional spatial coordinates of what is there, where the nerves are, how a structure is going to appear. And we're going to power our robotics and catheters and interventional techniques and doing site-specific delivery of biologicals and bioelectronics. So I'll sort of leave you with the very last slide. Things like Google Maps is why you have driverless cars. So we think the next era of interventions and procedures is going to be powered by knowledge that is going to utilize all the collective data that we get from billions, hundreds of millions of scans. And we're going to put that in the context of knowledge that we have a deep responsibility to make sure it's ethically obtained, and we're going to make sure that there are no paywalls and it's available to the whole world. So I'll stop here. I still have a minute if people have comments or questions. And again, my heartfelt thanks to everyone, and thank you so much for your presence here. Thank you so much.